Okay, everyone. Welcome to these next set of notes. All right, make sure you have your paper and pencil ready to copy down all these notes. And here we go. So the first thing that we always do is we identify the name of the notes, right? And the name of these notes is circles, right? We're still covering circles with an emphasis on the measure of arcs and central angles, right? So let us review that last time. We remember that, let's start here in the middle, that a full circle is 360 degrees, right? A full circle is 360 degrees. So that means that half a circle, right? Half a circle is 180 degrees, or a semicircle, right? And one circle is made out of two semicircles, right? Which 180 and 180 equals to 360, right? Perfect. Okay. And then the last thing that we are going to remember is that we have a minor arc and we have a major arc. So a minor arc is when the arc is less than 180, it's less than half the circle, right? And then a major arc is when the arc goes more than half the circle. So in that case, it's like that, and it's identified with 3 letters, whereas in the minor arc was identified by 2 letters, right? Then we remembered that the central angle, which is made from 2 points on the circle and 1 point from the center of the circle, right? The central angle, right, was equal to, right, let me pick that one here, was equal to the arc, right? The central angle was equal to the arc, right? So this angle right here, which is the central angle, is equal to the arc. They're the same measure. This angle is equal to the measure of the arc, right? Central angle equals arc, right? Let us actually write that down here. So central angle was equal to the arc, right? Arc measure. There you go. Okay, so those are the things that we learned. So let us get started on our examples here so we can work on what is found in the notebook, in the worksheet, okay? So first thing we do is read the instructions. It says, find the measure of the central angle indicated, okay? Assume that lines which appear to be diameters are actually diameters. So if we see a line going down the middle, it's a diameter, right? Going from one point of the circle to the other side of the circle, going through the center, it's a diameter, okay? So let's look at our first instruction here, our first example, which says we're going to find angle at USW. So we are going to find angle USW. So USW, right? So we are going to find angle USW. How much is this angle right here? It goes all the way there. Well, if you notice, that angle right there has 80 and 70. So what is 80 plus 70? So we're going to say angle USW is equal to 80 plus 70, right? Well, that equals to 80 plus 70. So angle USW is equal to 80 plus 70 is 150 degrees. Look at that. Perfect. Angle USW, right, is right here, is 150 degrees because it's 80 and 70 together. And 80 plus 70 is 150. Right? Perfect. Perfect, perfect, perfect. So let's go on to our second example here, right? Which says find angle XSU. Okay. Let's find angle XSU. So X, S, right? That's at the center, and U. XSU. So X, S, U. So we need to find that angle right there. But if you notice, I don't have these angles right here, right? But what I do have, thankfully for us, is I do have these arcs. From there to there is 40, X to T is 40, and from T to U is 90. And what we know, kiddos, is that the measure of the arc is equal to the central angle, right? Which is we have right here. The measure of the arc is equal to the central angle. So that means that right here, this is 40 right here, and this is 90 right there. So angle XSU is equal to 40 plus 90 because they're both part of the XSU. Look at that. They both fall under that. So 40 plus 90, so the answer is angle XSU is equal to 40 plus 90 is 130 degrees. And boom, look at that. There it is. There it is. XSU is 40 plus 90 is 130. Perfect, kiddos. Perfect. Look at that. Two done. Two done. Let's try our third example on finding the central angle, on finding the measure of the central angle. So let's take a look here. So the instructions here say find angle HCD. So let us indeed, kiddos, find angle HCD. Go back here, and I'm going to say HCD. HCD, which goes there, and it goes there. So I'm going to try to find that right there, right? Okay, what do? I don't have the arc. If I had the arc, then I would know what the central angle is, but I don't have the arc. But what I do have is this. Check this out. I have right here, from here to here is 60. So that means that this little angle right here is also 60. Right? That little angle right there is also 60. So I'm going to say this is 60 here. But how in the heck does that help me? This is from here to here is 60. But take a look, kiddos. Look at this. Check this out. Check this out. From here to here is a semicircle. Look at that. That is half a circle. Right? And how many degrees is a semicircle? Kiddos, 180 degrees is half a circle. Right? 180 degrees is half a circle. So that means that this angle plus this angle is equal to 180. So this angle plus that angle is equal to 180. So I'm going to write my angles here. Angle HCD, which is this pink one here. Angle HCD plus this blue one here is angle HCG, is the blue one. Check it out. Plus angle HCG. They equal a half a circle, which is equal to 180. Look at that. And now what I can do, guys, is I can substitute, right? I don't know which HCD is yet, so I'm going to leave that as HCD, angle HCD. But, kiddos, I know what angle HCG is. CG is, check this out, 60 is equal to 180. And there, let's just do some algebra, kiddos. Take 60 minus 60. So, check it. Angle HCD is equal to 180 minus 60 is 120 degrees. Look at that, right? It took a few steps, but we identified it, right? But what we did use is that we used this half. A circle is 180, right? So we used the 180 here, right? We used that right there. Perfect, 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 perfect. Look at that. So you're definitely going to see one kind of problem of each one of these in your assignment. Okay? All right. Let's take a look at these last three examples here. So our instructions here say, find the measure of the arc indicated. This time we're finding the arc. Okay? Assume that lines which appear to be diameters are actually diameters. So if there's a line that goes right down the middle, right, and goes from one end to the other, assume it's the diameter. It's 180 degrees, half the circle, right? All right, let's take a look here. So this says, find arc JKL. Arc JKL. So let us, kiddos, find arc JKL. Right? So JKL. Look at that. JKL. This is what we're finding. This is our arc. So, what lands under that arc? Well, check that out. I go here, and I go all the way around, and I end there. So, look at that. Look what falls inside. 55 and 150. So, arc JKL is equal to 55 plus 150, right? Look at that. They both fall under there. 55 plus 150, right? So arc JKL is equal to 205. Boom. There you go. Look at that. Look at that. We got this. We got this, right? Perfect. Make sure you write that down, kiddos. All right. Let's move on to the second one here. So let's see here. The second one says, we're going to find arc IJ. Arc IJ. So let's find arc IJ. So I and J. So the arc, I have to use this right here. Arc IJ goes from I to J. There's the arc. Look at that. Arc IJ. Right? So that means that my angle goes right here. Right? Well, what the heck is that angle? What is that angle? Well, we know that this is 50, so that means that this is going to be 52. And we know this is 40, so we know this is going to be 42. And check it out. This right here forms a half a circle, which is 180, right? So if we take 180 and we subtract 50 and we subtract 40, whatever is left over is going to be that right there. So we're going to take 180 minus 50 minus 40 is equal to arc ij is equal to arc ij. 180 minus 50 minus 40 is equal to arc ij. So 180 minus 50 is 130. Minus 40, 130 minus 40 is equal to 90 is equal to arc ij. And that right there, kiddos, is our solution. Look at that. Again, we used the concept that that's 180 degrees. It's a half a circle, right? And together, these three angles right here formed 180. I subtracted 50, I subtracted 40 from 180, and that gave me our solution. Look at that. Perfect, perfect, perfect. All right. So, let's see here. We want to find arc HD. Okay. Let's find arc HD. Okay. So H is there, D is there, so we want to find that arc right there. Okay, what do I have here? So this is telling me it's 50. Everybody see this little arc here? That's 50. Everybody see this? You see this arc here and this little arc here? They're all the same little arcs. A red little arc, a red little arc, a red little arc. That means, kiddos, that this is 50 also, and this is 50 also. All three of those are 50 because they all have the red little mark. And check it out. Look what I formed right here. A half a circle. So that means that these two together, 50 and this right here, equals 180. And if I have this, I have the arc, because the central angle is equal to, right? The central angle is equal to the arc. So when I do that, my half a circle is 180, and these two together are 180. So if I subtract 50, then the rest will be left right here. So I'm going to say arc HD is equal to 180 minus 50. Look at that. So, oh shoot, what did I do? What did I do? My bad. So 180 minus 50, so we get arc HD is equal to 130, kiddos. Look at that. Look at that. And there you go. Right? And there you go. That's the lesson right there. Right? So these are the kinds of problems you're going to see in the worksheet. Right? These are measures of arcs, measures of central angles. We remember that a whole circle is 360. We remember that half a circle is 180. And we remember that central angles are equal to the arc. Right? We have a minor arc. We have a major arc. Right? So those are the notes that you need for this lesson. Make sure you copied everything down. Thank you guys as always for being here. We'll see you next time.